Hello everyone, welcome to the session Programming for Problem Solving. Myself Navya, I'm an assistant professor from the Department of CSIT in MLR Institutions of Technology. In this session, we are going to see the topic Formatting Numbers in Programming Output. So, coming to the overview of this session, we are going to see what was the formatting numbers in program output, and we are going to see in that formatting integers and formatting floating point numbers and padding and alignment, as well as typecasting and type conversion. Coming to the formatting numbers in program output. So in C, we can format numbers in your program output using formatted inputs like printf statements and format specifiers. So here these allow you to how the numbers are to be displayed, such as specifying decimals, alignments, padding, etc. So we use specifiers for formatting integers. In order to format integers, you are going to use %d for decimal, %o for octal numbers, %x for hexadecimal numbers, %u for unsigned numbers. So here, let us see this example. If I am going with my number is 42, which is an integer data type. I want this in a decimal format, I has to use %d. If I want to have in octal format, I have to use %o, and if I want to have in hexadecimal, we have to use %x here. Instead of %d, we are giving the same numbers. So let us see a small example of this. See here, my number is 42, right? So what in octal, the number get changed to 52, and hexadecimal, it was changed to 2a. So this is how I can display the value in decimal format, which is %d. In octal format is 52. In hexadecimal, it was 2a. Coming to the formatting floating point numbers. Coming to formatting floating point numbers, you can use %f fixed point, %e for scientific numbers, %g for shortest representation. So here I am using %f, %.2f. So it will limit to the only 2 decimals, and scientifically %e. So we can use this one. If I am having a float number equals to let us say 8.987, like this. So what is a floating point number? Floating number is, we are going with %f, and scientific number will go with what's the next thing? 2 decimal places. I just want after dot to f. So if I want after dot, I just want to display only 2 numbers, then I can use dot to f. And coming to the scientific, we can use %e. So when I print C here, you will get floating number, which is I has given 8.987, but here I has got for the floating point after dot you will get 6 digits. So you has got, if I has given dot to f, which means I has got 8.99. So if I give if I want to give 3 decimal points, I has to use 0.3f. So then you will get 8.987. And scientifically, see here what I got for scientifically 8.987, 3 zeros, e plus 3 zeros. So this is how we are going to use formatting floating point numbers here in the scientific notation, as well as limit of 2 decimals. If you want to give 3 digits, you have to give *3f, like this. Coming to the third one, padding and alignment. Padding and alignment, which is used to specify the width, padding, as well as alignment. So width is nothing but specifying minimum width. Okay, percentile width. If I want to give some 5 spaces, then I can go, it was right aligned. Okay, so width, you has to give 5 spaces after particular statement. After this some x equals to, I has to give 5 spaces. I has to use width here. Then padding, use 0 for 0 padding. If I just don't want to give spaces, I has to use 0 padding. And alignment, if I want to use left alignment, I has to use hyphen. So let us see this example also. So my number is 42. So here I am right aligned equals to C here. When I use 5D, I'll get the 5 spaces here. When I use left aligned, it got to left. So minus 5D. Left side you has got. 0 padded. If I has to get 0, 5D means after 2 spaces and 3 zeros, and you will get 5 numbers total of. So 3 zeros and 42. This is how the padding will happen. So 0 padded as well as this one. Coming to the formatted with field width and precision. So here we can go with width as well as precision together. So if I want to have some x equals to, I has to go with some space, 2 spaces, and then I has to get 5.368 like this. So in order to use this width as well as I should get after decimal point, I has to get only 3 digits. Then I can use this one. See here, if my floating number is 123.456. So width I has to use 10 and precision 2. So after dot I has to use only 2. So I can go with 10.2f. So and left alignments, if I give minus like hyphen, I can give left aligned. So let us see this example. Float number, which is 123.456. So I just want to use 10 width and 2 precision. So which is percentile 10.2 f comma number. Okay. Similarly, if it was left aligned, same I am going to take 10.2. Okay. So when I execute this statement, see here what happened. I has got 10 spaces here, as well as after dot I has got only 2 numbers. Similarly, if it was left aligned, I has got after, from this it was taking 10 spaces, and then you will get this one 123.46. This is how the left alignment formatting with field width and precision will be there. So this is how the alignment would be happen here, and width with 2 decimals. After point, if you want to have 2 decimal values only way. If I want to have 3, then you can take 0.3 like this. Coming to the type conversion and casting. So this is another concept, type conversion and type casting. So first, in order to evaluate some expressions, first we have to check whether the expression is a integral expression or constant expressions or floating point expressions. If I got the combination of together, so what I has to do? So for example, the multiplication of an integer data with a floating value, what it results? It results in a floating value, right? So you has to convert that particular result into floating value. So the expression should be converted to float. So like that, the type conversion, it might have internally or it might have externally too. So there are two different methods in C in order to have this concept. One is type conversion, the second one is typecasting. So coming to the type conversion, the process of converting the data value from one data type to another data type automatically by compiler itself. Then it is said to be type conversion, or we can call it as implicit type conversion if the compiler itself has converted the data from the data value from one data type to another data type. Then it is said to be implicit data type, implicit type conversion. So the implicit type conversion will be automatically without any notice. The compiler itself will performs this particular thing. So for which U has to be converted. So here, when it comes to the higher to lower, this would be happen, which means if I'm having float value, that can be converted to integer automatically. When I'm having integer value, that could be converted to character value automatically. When I have the character, that could be converted to boolean automatically. This is how the implicit type conversion works. So from higher order to lower order, higher conversion rank to lower conversion, you can use implicit type conversion. Let us go with a small example or program for this. See, a small example. We are having the ASCII values, right? So I'm taking a number int n equals to some 69. Okay. So I'm printing that value percentile C. So the number I has given the value as integer, but here I'm printing it as a character. So does it execute or give an error? So it don't give an error because the compiler itself converting the value to the character. So the integer is of higher order and character is a lower order. So integer value 69 was converted into ASCII character, which is E. So the compiler itself will convert the integer value to the character value here. So this type of conversions from one data type, integer data type to character data type, or one data type to another data type, from higher data type to lower data type, it is known as implicit type conversion. So this would be performed. You need not to do anything. You has to convert this. So the compiler itself automatically converts this one. So that's why it is called as implicit type conversion. So this was performed by compiler. So this is how the type conversion will be happen. Coming to the typecasting, if I want to convert from lower data type to higher data type, then the conversion is said to be explicit type conversion. This can be performed using unary cast operator, which is nothing but the target data type followed by expression or data value. So to convert the data from one data type to another data type, if we specify the target data, then it is said to be explicit type conversion. So in this, the compiler converts the data from one data type to another data type, but implicitly. So sometimes you might lose the data. In such cases, we are going to use the explicit type conversion. Let us go with a small example program for this. See here. I just want to do the average of two numbers. So I'm taking two values here. Let us give you one example so that what is the use of this particular type conversion we'll see. Average equals to m plus n divided by 2. Okay, finding the average of two numbers. When I do this, what happens? See here, I'm giving two values, which is 5 and 6. 5 plus 6 by 2, which is 5 plus 6, 11 by 2, which you have to get the value in float. But what is the value I have got? 0. So, which is looks like data loss for this, isn't it? So, if I convert this into float, so the type conversion, when I give the same values 5 and 6, sorry. What happens? And sorry, I took percentile F. So sorry, I'm taking a float here. When I 5 and 6, 5 and 6, 5 plus 6 by 2, which I have got only 5 value. 11 by 2 I has to get, which is 5.2 I has to get, but I have got only 5 as the value, isn't it? So I has lost 0.2 value here. If I use float type conversion, I'm converting this particular target data value or the expression into float converting. I'm converting it into float. So when I give the same values, see here, what I got is 5.5, which is an exact value. So there is no loss of values, loss of data here. So this is how we will use the type conversion in two ways. First one is automatically, which is called as implicit type conversion, and the second one is explicit type conversion. In implicit type conversion, we are the compiler itself, it will convert the data from one data type to another data type, and in the explicit type conversion, we has to convert that into explicit type conversion such that no values to be missed. Coming to the summary of this session. So what we have seen in this session, formatting, output statements. So we have seen first one, integers. We can print integers in three types. One is decimal values, octal values, and hexadecimal values. Similarly, for the floating values, what we can see, for the floating values, you can use the precision and width. So, you can use, percentile F for float, percentile E for scientific values. If you want to print two decimals, you can use 0.2F, or if you want to print after decimal point, if you want to print only three values, you have to use percentile 3F. And next we have seen padding and width. If I want to give some space, so you can use 5D. So it will give, before printing this value, it will give 5 spaces. If I give 0 spaces, 0, 5D. So if my value is some 42, it will give 3 zeros and 42, which is total of 5. And next, if I'm having some 0.2F, so if I'm giving 3.2, it will give 3 spaces, and after point, for example, my data is 5.36, it will give 3678. So if I give like this, it will give 3 spaces, and after that dot 5.36 only, after point 36 characters only. This is how, and we have seen the left alignment also. In order to have the left alignment, if you have to go with the left alignment with the left and right alignment. If I want to go with the left alignment, you have to use hyphen, and if I want to right alignment, you can directly go with the values, this one, width. So this is how we have seen the formatting, output, printing statements in output, and later on we have seen type conversion concept, typecasting concept. So we can call anything type conversion or typecasting. So here in this, type conversion means implicit type conversion or casting. This is called as explicit type conversion or casting. Implicit type conversion, when the compiler itself convert one data type to the data value to one data type to another value, another data type, then the type conversion is said to be implicit type conversion. So this would be performed by compiler itself. We have seen the examples here. Explicit type conversion is converting a data value into one data type to another data type by user itself, explicitly by ourselves. Then the conversion is said to be explicit type conversion. So for the syntax, you will have target data type. You have to use a parenthesis followed by expression or data value. So that would be, in order to prevent the loss of data, we are going to use the explicit type conversion. This is what we have seen in this session. Thank you everyone.